All right, so let's talk about the domain of a composition. Now, because we're feeding x into g of x, and then we're taking g of x and feeding it into f of x, that means that the x values that we choose have to be in the domain of g, and then because g of x is the input to f, then g of x has to be in the domain of f, which is a lot of words, but it makes sense. So it'll probably make more sense if we look at some examples here. So let's take a look at this next example here. And we're going to look at the domain of these compositions. All right. So let's start with this first one. We've got a bunch of different functions here defined. And so we've got f of x is 3x minus 6. And then we have a g of x, which is just 2 over x. We've got an h of x, which is the square root of x plus 3. And then we have k of x, which is 5 over x. All right, so we want to look at, in this first part, we want to look at the domain of k of g of x. So first of all, let's look at g of x. All right, g of x is 2 over x. All right, so what's the domain of g of x, right? The domain is basically anything but 0, right? X can be anything from 0. So the domain of g of x is just x cannot be equal to 0. All right. So that's one restriction on the domain. And now let's look at k of g of x. Okay, so we're feeding the g of x function into the k function. And so the k function is 5 over x. So we have 5 over, and then g of x is 2 over x. 2 over x. All right. Now, let's simplify that. So, again, so this is just dividing 5 by a fraction. So I'm going to take 5 and multiply it by x over 2. So we end up with 5 halves x, right? Or I could do 5x over 2. It's the same thing. So, for that, there's really no restriction on that. X can be anything when we compose k of g of x, right? The early x can be anything. So the only restriction is on x due to the domain of g of x. Okay, so just remember that the x values we use have to, if we're doing in this case we're doing k of g of x, so the domain of that composition the x values have to be in the domain of g of x, and then the g of x values have to be in the domain of k of x. Okay, so essentially down here, 2 over x cannot be equal to 0, which doesn't happen anyway. So we're fine with that one. So the end result is that the domain of this composition is x is not equal to 0. And that's it. All right, so let's do something similar for the next one. We have a composition of g with f of x. All right, so for f of x, let's look at the domain of f of x first. Now f of x is just, it's off the screen, but but it's 3x minus 6. All right, so this is fine, for all real numbers. All real numbers can go into this function and it'll be, it'll work, right? So the domain is all real numbers. All right, so we don't have any restrictions on the domain of f of x. So don't have any restrictions for the domain of f of x. So now let's look at g of f of x. All right, so we're going to take the g of x function, which is 2 over x. All right, but we're going to feed in f of x, so it's 3x minus 6. Okay, so that's what our composition looks like. And so what are the valid f of x values? Well, we know that 3x minus 6 can't be equal to 0, right? Because we can't divide by 0. So what does that mean for x? Well, let's just rearrange this. We get 3x equals 6 cannot equal 6, and then x cannot equal 2. All right, so x cannot equal 2. All right, so we have the combination of the domain of f of x with the we know that the because the output of f of x is the input to g of x, then x cannot be equal to 2. So our domain, our final domain is just that x just cannot equal 2. Okay, so that's our domain for that function, or that composition. All right, so those are our two domains. All right, so let's finally look at this last one where we have h of f of x. All right, so let's first of all look at f of x, and f of x is the same as what we had before. It's 3x minus 6, and the domain is all real numbers. Numbers. I should have put a S on that. All right, so now let's look at the composition. H was the square root of x plus 3. Okay, so we want h of f of x. Okay, and h of x is the square root of x plus 3. So the input plus 3. Okay, but the input's going to be 3x minus 6. All right, so let's simplify that a bit, and we get the square root of 3x minus 3 when we combine the minus 6 and the 3. All right, so it's a square root function, so we know that we can't take the square root of a negative. All right, so it has to be greater than or equal to 0. The input to the square root has to be greater than or equal to 0. So we know that 3x minus 3 has to be greater than or equal to 0. So what does that tell us? 3x is greater than or equal to 3, so x is greater than or equal to 1. All right. So put those together, and then we see that the domain of the composition is just x is greater than or equal to 1. All right, so that's it. Those are 3 examples here on domain, and I'll meet you in the next video for the next example.